All right, well, welcome everyone to Calculating Safer, Healthier Spaces. This course is approved for 1 hour in continuing education units among many different credentials, as well as AIA, Health, Welfare, and Safety, which may make it applicable to your state-based design or contractor license. This session is brought to you by the nonprofit, the Green Home Institute. Our mission is to empower people to make healthier and more sustainable choices in the places we live. And my name is Brett Little, and I'm the program manager here at the Green Home Institute. We really want to talk about tools and give you a tool that you can use to get us back into buildings safer and healthier, that go way beyond this current pandemic issue and help us just live healthier lives. And we want to give a shout out before we get started to our top tier sponsor for allowing us to support our mission, Build Equinox, featuring the Serve2, a smart ventilation system. Unlike traditional ERVs or HRVs, it features many qualities of smarter, balanced ventilation and feedback monitoring. With a standard ERV or HRV, you get a constant low airflow rate with no relation to actual indoor air quality or occupancy. So you can see here for the first 3 days when the home is occupied, the air quality is poor. The ERV just can't keep up. When the occupants leave on vacation, the ERV keeps ventilating, wasting energy, wasting money. Since the Serve actually monitors air quality, it ventilates only when needed, and it can ventilate up to 300 CFM, quickly purging pollutants from the home. When no ventilation is needed, it can recirculate the air, unify the home, providing some additional heating, cooling, or dehumidification needs. The Serve does this by monitoring both CO2 and VOCs to determine what's going on in the air based on set points for your client's lifestyle. Instead of an ERV exchange core, the Serve uses a high efficiency heat pump to exchange outdoor and incoming air, meaning conditioned, comfortable air that unifies the home instead of dragging away exterior rooms from the comfort. Easy to access for changing and filters up to MERV 13 standards. What's really cool is that it's manufactured right here in the US, in Illinois, in a facility being powered by 100% solar. And it pairs well with a lot of our other friends like Rheem heat pump water heater to boost capacity or work with Radiant, with Mitsubishi mini split systems to move air around appropriately and comfortably, or our friends at Water Furnace with the GeoBoost ground loop heat exchanger. Check them out over at buildequinox.com today. And then thanks to our second tier sponsor, Great Lakes Passive House Supplies. They offer a very simple concept, frost protected shallow foundation ICFs and air heated radiant floor systems, along with radon protection as well. That's Great Lakes Passive House Supplies.com. Before we hand it over to our speaker today, I wanted to talk about some important things, and then I will be posting some of these links into the chat for you as well. So the first one is something that is really important to understand, and this is the CDC has recently backed off, stating that the transmission of COVID-19 is primarily through surfaces. And in fact, that's rarely where it could even occur at. So this is highly concerning. Where is this coming from? How are we getting sick? You can check that out at that link and we'll share it. On the flip side, we're maybe taking some extreme and costly remedies that may be causing other health problems, especially in our schools, to remedy this. And so there is an open letter from many of our friends on Medium, and check it out. And we hope you'll take it and use it to get the word out to public spaces and school systems and wherever you work, that ionization, may not be that effective against COVID and may be dangerous to our health. So we'll send a link to that there. So what do? We know that there are studies and more coming in data showing that we need to increase ventilation and filtration. That's, if you can understand that basic as a starting place, that's where we'll go from here in the rest of this conversation on what to do next. But we can see up to 93% respectively decreases in ineffectivity from one of these most recent studies that's still available for you to download for free on Science Direct. And states are funding this. Here in Michigan specifically, Michigan K through 12 public school HVAC assistance can help pay for these improvements. Other states have all sorts of funds that are coming from the COVID relief bill. So go check it out and get plugged in with your school systems and other buildings, because there is money available to make this shift that's going to help us way beyond. So what do we do and how do we figure it out? And that's where I'm excited to introduce Ty Newell here. He is the co-owner, co-founder of Build Equinox, as well as retired from the University of Illinois as an assistant dean in the College of Engineering. And Ty, this is probably your 100th time here on one of our sessions.
Yeah.
And so we're really excited to welcome you back. And it's, bittersweet to have you back again talking about COVID-19. Unfortunately, we still have to be dealing with this, but we're so thankful for all your help and guidance and some of the resources you're putting out to help get us back to work safely. So with that, Ty, I will stop talking and I'll hand it to you, and thank you for joining us.
Great. Thank you very much, Brent. I think I'm in control here, and let me see if I can do. And okay, I think I'm in control, or as much control as I should be allowed. And those two papers that Brett just showed, it was a laundry list of people who I look to for information that this presentation and previous ones have been built on. People like Dr. Nora Wang, who was with Pacific Northwest National Laboratory with the paper that Brett just cited on how contagion is spread throughout the air within our buildings, and basically the inadequacy of today's building ventilation standards. The letter that you saw signed by people like Bill Bonfleth, professor at Penn State, who, along with Professor Shelley Miller at University of Colorado, international experts in ultraviolet germicidal irradiation. That's the basis for what I'll cite within this work. Brent Stevens with Illinois Institute of Technology, who's done fundamental work on how filtration, filters at MERV 8, MERV 13, MERV 16 levels, that a MERV 8 filter is like having no filter in there at all when it comes to filtering out contagion. And filters that are MERV 11, 13, 16 progressively improve the ability to pull contagion, virus and bacteria out of the airstream. And so this work, which as Brett mentioned, this is the third, and yeah, aren't we all getting sick of me talking about trying to avoid getting sick with COVID? But this message hasn't changed. So a year ago when I gave the first talk, it was on airborne spread of contagion. CDC and others had not allowed that as a possibility. It was all close contact. It was all touching things. And then about 6 months later, I gave another talk as things were becoming better understood, and they're showing, hey, we're understanding this. We can predict it. We know why people are getting sick. It's bad behavior and it's poor building ventilation. And but still, what was lacking was the ability to give tools to everyone, so that you're just not waiting on CDC or ASHRAE or others to provide more fuzzy and perhaps confusing and contradictory details on what should or shouldn't be done. And so again, this message is exactly the same as a year ago, but what's different is that now this message is meant to provide tools to you. And as Brett mentioned, there's money ready. So you need to be shovel ready in your schools and other institutions so that you can understand what you need to do, and then have a basis without you being a facilities expert, but being a stakeholder in making sure your buildings are healthy, and understanding the cost so you can discuss this with people who are, say, more expert in building science, but that you're not left out of that discussion. You're not just simply throwing the details over the fence to others. And so that's what we're going to talk about today. And basically, as the mission statement, I mean, this all goes together. helping us live sustainably in a healthy, comfortable manner. That's where it's at, and basically living on our daily allowance of solar energy. That's what drives me and the folks that it's a privilege to work with at our business and many others like at the Green Home Institute. So here's the discussion topics. They haven't changed, but new information, new ways to say it, and then this, what I call the COVID Safe Space Calculator, an ability to allow non-building science experts to look at within their situation that you'll know how to define, and then see what measures as far as fresh air, quantitatively fresh air, filtration rates, ultraviolet germicidal irradiation, and other measures, how to change that, what the impact will be on energy. And the bottom line, which we've been saying for years and years, and we've known for years from research from many people, Lawrence Berkeley National Lab, Danish Technical University, Harvard School of Public Health, that we know where air quality should be, and why our standards don't reflect that is just, it's hard to imagine, but we need boots on the ground to start making these changes. And so the good news is that what we need to defeat COVID is exactly what we need in general to keep us healthy, to reduce our sick days, to reduce asthma and allergy attacks, to make us more productive. And so, so it all goes together. And the one message before I put you to sleep with another long monotone webinar, the one message to remember: carbon dioxide, that's your gateway to knowing if you've got sufficient fresh air. And today's building standards roughly result in an average of 1,200 parts per million of carbon dioxide. That is at nominal 20 cubic feet per minute per person or less, which today's building standards give us. And in the words of Florence Nightingale, who knew it more than 100 years ago, that we don't purge our entire building with sufficient fresh air, you're going to get sick. And carbon dioxide is the simplest and most cost-effective way to determine that airflow rate. Going around to every register and then every crack and flue to add up how much air is coming in, it's not practical. It's expensive. It's not accurate. Carbon dioxide lets you follow the dynamics of it. So as wind speeds change and infiltration changes, you can see whether or not your ventilation has made up enough fresh air as your activity and occupancy changes. So over on the right here, if I measure 800 parts per million and people are at roughly office work type activity level, sedentary level, a metabolic rate in that lower table of about 1.2 to 1.5, I know I've got about 40 cubic feet per minute per person of fresh air coming in some manner. Maybe in my ventilation, in a passive house for sure, mostly through ventilation. In a less sealed house, perhaps mostly through infiltration. But in either case, enough fresh air to help dilute contagion, as we're mostly talking about today, but also to help my brain function better. But if I'm exercising and or if I'm under heavy exertion, that can be a factor of 10. One person can be as if there's 10 people in that building space. And yes, you need 10 times as much airflow, fresh airflow, when you're under that level of exertion as you do when you're sleeping. It's a very dynamic situation. Over on the left, I've got kind of a small army of people now sending me pictures, and if you want to join that army, please feel free to email me a picture of carbon dioxide readings you take in different places that you wander into. Couple $100, maybe share the cost, and then share the sensor, but go around and just out of curiosity, see what the carbon dioxide level is. You can't smell it. This picture, in which 8 out of 12 pictures here is more than 1,000, 1,100 parts per million of carbon dioxide, Today's building standard, as I mentioned, about 1100, 1200. So like this barbecue takeout, the State Department of Motor Vehicle Office, we'll look at a little more data from that later on. But look at the car over in the left-hand side. If that car's ventilation is in recirculation mode, it's about 17, 1800, and just a brief car ride with somebody infectious, you're probably going to catch it. But if you have the car in non-recirculation or fresh air mode, and in this case, there were 3 people in the car, it dropped it down to 600 parts per million, quite fresh air. But again, the smell, you can't tell the difference in odor between those two. You can see the physical therapist up on the upper right, the reception area, that's not good. And then the session room, that's even worse. And look at the humidity level, 74%. That just looks uncomfortable from that aspect on top of undesirable air quality. And then another one I want you to remember, look at the big box store on the top row and then over in the bottom right, below 800. Is that coincidence? Is that just happenstance? Why are they already at this double the fresh air rate of our building standards? And I guarantee you, and if you find a big box store, without naming any, that has, say, 1,000, 1,200, let me know. I'd be very curious. But my experience is that big box stores, big chains, that they're already at 800 or less, and we'll discuss why. Every space should measure CO2. In the case of the smart ventilation system, Brett mentioned, and over on the left, so in homes that are using our system, yeah, you absolutely know CO2, and you can do something about it. It doesn't just tell you, hey, air quality is bad, I don't know what you're going to do about it. In our case, you can do something about it. And every room could have, say in this case over on the right-hand picture, a wireless, battery-free, solar-powered CO2 temperature humidity sensor. And that can chirp a message back to a smart ventilation unit saying, hey, let's put more fresh air over in this region. Let's open some dampers to this area, close some to the areas that are that have good air quality and don't need so much fresh air, so we can more precision match fresh air and comfort to those areas that need it. And wearables, they're not in the distant future. They're coming along now, as you can see me with this kind of name tag device that someone we know is working on, and I think before long, wherever you go, you'll know the air quality around you. And then let me just try this. Alexa, what's my CO2?
Sir, CO2 is 706.
So I'm sitting in my house. Of course, it's got smart ventilation, and I don't know if you could pick that up, but Alexa just told me that the CO2 in here is 706 parts per million. And you can see live data online from our website, and that will show you the history of air quality and comfort conditions in our house, and let you see that our setting is at 800 for our house. Summer, winter, I don't care what the extremes are. It's more important to get fresh air than to try to protect the ventilation system. Just briefly on today's ventilation standards. Small homes are penalized, as they are in many other ways, but homes with starting families, homes with lower income, when you look at the ventilation standards, a 2-bedroom, 1,000 square foot mobile home or apartment with 4 occupants, they're going to be getting about 10 CFM to 13 CFM per person based on Passive House Institute standards, or ASHRAE 62.2, the recent version. 62.2 2010, that EPA's current indoor air plus standards use, allows 2010 version of ASHRAE 62.2, and that would drop you down to about 10 CFM per person. Large homes go the other way. 4,000 square feet, 4-bedroom home, 2 old people like my wife and I shuffling around, there would be way too much airflow in the house with that. And of course, associated with that is drying your home out in the winter and excessive energy use because of that, plus without it being smart, not compensating for wind speed and infiltration. And when you look at these standards, you find out, for example, in ASHRAE, less than 50% of that formula is for people. Most of it's based on the building. And you look at Passive House Institute, it ignores occupancy. It only looks at air changes per hour. That's not a people-based measurement. We need to know fresh air per person. And why isn't there any difference in building standards for activity level or between electric and gas cooking? I'd rather have today's modern vehicle with an oxygen sensor and a catalytic converter idling in my living room than I would a gas stove. Just to make this a little more real, Ben and Alex, ostensibly to collect data, but possibly to isolate me so I'm not as much of a distraction as usual, put me in our control chamber. We use it for energy experiments as well as air quality experiments, but it's just like a walk-in cooler. Lock me in there. It's a pretty good size space, enough room to move around or sit at a small desk. And so in the one case you see here where I'm sedentary doing computer work, that CO2 rises, and relative to the infiltration or leakage rate of this chamber, that it only takes about 8-9 minutes for it to go from a nice 500 parts per million level up to 1,000 parts per million. And then you can see by sitting in there for about 40-50 minutes until they finally let me out, that it went up to an undesirable 2,500 parts per million. Now, when you look at the temperature and humidity data, which you can see in a recent newsletter article that we posted, those didn't go up to such extreme levels. They increase a little bit because humans are heaters and humidifiers, and about all of our activities, washing, turning things on and off, these are also heating and humidifying activities. But it doesn't go up anywhere near as much as what air quality changes. And when I'm exercising, and in this case, I was simply taking a 10-pound weight, lifting it from the floor up to a table, and then lifting it from the table back to the floor every 5 seconds for a 2-minute period with a minute of rest, because I'm old and decrepit. So Ben and Alex let me have a minute rest. Then I do that again. That took 2 minutes to go from 400 to 500 parts per million of carbon dioxide up to 1,000 parts per million. So in a gym, for sure, or an exercise center, you should have more fresh air per person than an office space. Why don't the standards reflect that? And why don't our building systems? We're starting to see some smart or demand control, but not much. And out of this data, I can back out that our chamber is receiving about 1.5 cubic feet per minute, which is about 4 times my respiration rate, but that's not enough to keep the air pure enough. You need much more to hold it at what we recommend, 800 parts per million. And exercising, also out of this data, I could do an analysis that showed when I'm sitting at the table, I'm generating about 0.03 kilograms of carbon dioxide per hour. When I'm exercising at that level, I have about 3 to 4 times the metabolic rate. I should have 3 to 4 times the amount of fresh air flow in, because I'm generating about 0.12 kilograms of carbon dioxide. So when we look at today's homes, unfortunately, there's kind of a disjointed approach that filtration, fresh air flow rate, and then potentially air purification. And as Brett mentioned, there's a bunch of new technologies coming out, but they have not yet been tested in a manner that allows them to be appropriately designed. But that doesn't stop them from going in many, many buildings. And so it's a cautionary tale to understand that these are actually effective, how you do design them in, and then whether or not there's any, say, degrading impact, such as producing ozone, also at the expense of your health, while perhaps disabling or killing a contagion. And so ultraviolet germicidal irradiation is a proven technology, about 100 years old, and we do know the dosage, we know how to operate it and operate it safely. And so when I say air purification, that's what I'm referring to, as opposed to some of the newer ionization and other systems that may be effective, but need to be tested in a neutral balanced approach. University research, basically. I want to mention, though, I can't tell you how many times I hear from people. I live in a leaky home. I've got good air quality. I don't need ventilation. Where the leaks occur, where you live, are two different things. Here's a 1950 era leaky home, a blower door level of about 8 or so. It's had no ceiling, no additional insulation since the 1950s. It has 5 occupants. The 2 young children that share a bedroom, you can see the gray line when they go to bed, the CO2 in that room just skyrockets. And then when the parents open the room at about 9 o'clock, as the noise is quieted down, it somewhat levels off. But basically at these CO2 levels, if one of them gets sick, the other's going to get sick. And throughout the house in general, with relying on when the wind blows and construction flaws for your fresh air. Some days might be low, other days are high, and basically overall, if someone is sick, everyone gets sick. Cold, flu, COVID. Here's what should happen. An integrated approach, a systems approach to managing your fresh air and air filtration and potentially air purification. And when you put these together in terms of a contagion, they work together. Fresh air dilutes the contagion, and air filtration removes another part of it, and ultraviolet germicidal irradiation can then kill a certain fraction of what's remaining. And when you put these all together, there's a synergistic effect such that the fraction of microbes and the probability that if an infectious person's in that space, that you'll get sick is lowered to a level that no longer self-sustains the disease. Brett already showed this slide, so I won't discuss it, just that with smart ventilation, we can bring in the fresh air when you need it, how much you need, and then you don't have to guess. And as I tell people, a broken clock is correct twice a day. Today's ventilation standards are never correct. So let's, as an engineer, I like to look at limit. What's the worst case? What's the best case? What might horrify a bunch of people is to say, let's double today's ventilation standards and let's not recover any energy. Just, if it's 22 degrees outside, like most of the Midwest average temperature in January, East Coast, West Coast, and everywhere in between, Salt Lake City, where I went to grad school, that just bring in that 22-degree air, heat it up to 70, 72 degrees with a good high performance, low temperature heat pump, geothermal, mini split, or whatever flavor, and at a utility cost that, would be, you'd put in a solar system or wind energy generation that's gonna forever produce 12 cents per kilowatt hour energy. So without any energy recovery, what's that cost per person per hour? Just think of minimum wage, how poor and non-living of a wage that is. How does that compare? Well, 20 CFM per person, bringing in 22-degree outside air up to about 70 degrees or so. Under these conditions, that's going to cost you maybe a penny and a quarter per hour per person. And if I double that ventilation standard to where I think it should be, that's going to cost you a whole whopping 2.5 cents per hour, maybe about 1.5 cents per hour more. Aren't you worth it? Aren't you worth an extra penny and a half to whatever your hourly wage is to keep you healthier, to keep your brain functioning better, and to get rid of COVID? And let's look at some of the effects of that. With today's building standards, less than 20 CFM per person, That's the range where sick building syndrome occurs. That's where endotoxins build up and act as an adjuvant to make you feel even more sick and more fatigued, on top of the increasing concentration of volatile organic compounds and contagions that make you sick. And the dissatisfaction scales, it correlates strongly with carbon dioxide level. So today's building standards, you've got a good 20% or more of the general populace not satisfied with the air quality. And again, it's often in these surveys, people can't describe an odor, but they can sense a dissatisfaction with the air quality. And the lower that airflow rate goes, the higher the dissatisfaction. You get to 40 and cubic feet per minute per person, and now you see that people sleep better. April's ASHRAE Journal article, an excellent article summarizing a lot of the fundamental research that's been done on this. No ifs and buts about it. As you get above 800 parts per million, your sleep efficiency, your ability to get to sleep, your next day's performance, all of these things start getting degraded. And at 40 CFM, you start having diminishing returns. That seems to be enough where going beyond that there's not noticeable gains in these different areas. But no sick building syndrome. Oh, and I mentioned the big box stores. Big box stores are already at this 40 CFM per person. And I don't know anyone directly there to talk to. If you know someone and can connect me, I'd appreciate it. But I suspect the reason they're already at this building standard is that they know the difference between 10% dissatisfaction and 25% dissatisfaction may be the difference between a customer choosing that big box store over this big box store. And they don't want that. 10% of potential customers lost just because they somehow like the air quality better in that store to that store. They're not going to accept that. It's worth it to them to bring those extra customers in. Sick days and ventilation. And this is built on solid data. I mean, over 3,000 to 4,000 people spread among dozens of buildings. A study by Dr. Donald Milton at University of Maryland now. He did this study in around 2010 when he was at Harvard. And so this modeling that I've done makes use of that, those results. But basically at 20 cubic feet per minute, and using that as the standard building ventilation, and you can see over to the left, that would mean 100% of sick days, and what I've assumed is 2.5 sick days, which is about typical for many regions and many situations, and that would have a zero net benefit as far as a cost or a savings. And if we increase, following that brown line to the right, to 40 cubic feet per minute per person, we would be about here, and we would see that sick days would get reduced, maybe about 15% or so. But then let's also recirculate through a MERV 13 filter, something that removes contagion. And we're not talking about COVID here, we're talking about seasonal flu and colds, okay? So COVID layers on top of that now. This modeling was done pre-COVID. This has been around for quite a while now, and we've been telling people about this for several years now. Well, as I increase fresh air, and then I have a similar amount of air recirculated through a MERV 13 filter and further remove contagion, I get sick less often, and by about 40% now. And this is what Milton saw in his study of 3,000 to 4,000 employees scattered among dozens of buildings. The lower but still standard ventilation level buildings versus the ones at this level, it was equivalent to what you would see with flu vaccination. Flu vaccinations would drop sick days on average about 40% as well. So just some fresh air, just some filtration, and we've got flu vaccine effectiveness. Layer the two together, well, as we've been seeing this year along with COVID precautions, The flu is almost non-existent, and it is a relatively new disease, just over the past century or so. So perhaps we can eradicate that if we're careful and monitor and behave properly during that season. Well, the cost differential, the savings as we do this, is about 5 cents per hour per person. When you take the 2.5 sick days, drop 1 sick day by better filtration and air quality, and assume a sick day is worth about $500 of missed work and doctor and this and that expense, that we got 5 cents displacing that 1.5 pennies per hour per person that we had under standard ventilation. You've paid for it by at least a factor of 4 in January without any energy recovery. Of course, energy recovery makes it even better. So are there other benefits? Yes. Harvard T.H. Chan School of Public Health, Professor Joe Allen and colleagues at SUNY Albany and Syracuse University saw the degradation of cognition productivity, of brain function, when you're at 20 CFM, and again, using that as standard, and it's essentially, that's about 100%, but there's 9 areas of cognition measurements that go into this average. So it's not quite at 100% here, but, and not quite at 0% when we're at 20 CFM for this modeling. But when we increase airflow, we get about 10%, 12% improvement in brain productivity. And over here, we see that that's worth 50 cents per hour per person, assuming a person's worth $50,000 per year, $25 per hour. Are we worth $50,000 per year? I don't know whether or not we're paid that much, but let's say I'm off by a factor of 10, so we're only improving productivity because other things get in the way of that. Improving productivity by 5 cents per hour per person. Well, I've reduced sick days by about 5 cents per hour per person. So I've got 10 cents per hour per person savings versus 1.5 cents per hour per person without any energy recovery. And for sure, I can easily get 50%, if not 70, 80% out in a cost-effective manner on energy recovery. So we're talking about several times what the energy value is of improving this ventilation. So as people wave their hands and say, that's horrendous, the double ventilation, our system can't stand it. We can't handle a MERV 13 filter. They need to look at the basics, and I'll guarantee you, you put in a MERV 13 filter, as a California Energy Commission experimental study demonstrated, MERV 8, MERV 13, the difference in pressure drop and in impact on fan airflow is not in the filter. It's not in the filter level, it's in the quality of the filter. MERV 13, MERV 8 often have the same pressure drop, and you're not going to see that show up in a utility bill or difficulty in getting airflow through. And if it does seem to show up in a difficulty in airflow getting through, you need to get somebody that knows something about fans and ducts and how to operate them properly. So let's look at some costs just briefly. Here's a project going on right now. My home institution, University of Illinois, mechanical engineering building. It's got a new wing and then an old renovated wing, about 100,000 square feet. And these mechanicals, the MEPs, I was on the building committee, and so these are real costs. The costs on the new side and the costs on the renovated side, about $50 a square foot for the HVAC and modern HVAC. Let's look at residential, where people are trying to get this down to zero. Why? This is the most important part of the house to keep you healthy and comfortable. If you're not healthy and comfortable, if you're shivering while trying to read a book or trying to do your homework, or just catching colds more often because you're not comfortable, and that impacts your ability to stay healthy. Why do you want to get that to zero? It's not a big cost. Yes, I know you'd like to take that expense and put that into more granite countertops and stainless steel appliances, but but save a little bit for your health and well-being. And you look at these two fantastic homes, a wonderful passive house, a Tom Bassett Dilley designed home here in Illinois that just has this very simple cookie cutter, high efficiency, low temperature ducted mini split, smart ventilation system and heat pump water heater. That configuration in the Google SketchUp to the right shows how those are somewhat laid out with sliding doors and including also the laundry. You slide the door one way, you've got laundry, you slide it the other way, you've got access to heat pump water heater and smart ventilator. You've got 30 square feet in that. And you've got about $10,000 to $15,000 for mechanicals. And in either of these cases, the house on the left, a 1,200 square foot manufactured high performance home, it has less, 20% less energy usage per year than either FIAS or Passive House Institute requirements for energy loading in a very harsh climate and very difficult to do in a small home environment. And it has a mechanical room that looks like the one on the left, about a 5 by 6 foot walk-in closet that also includes electrical distribution panel, a room for an inverter, as well as a battery pack. And so $8 a square foot out of a $100,000 to $200,000 house, that seems like a pretty good deal, especially when you look at the commercial side. And just on the growth side of things, as far as costs, this commercial building, it's a building we studied about 8 years ago. And as this information started coming out on performance and productivity relative to carbon dioxide at levels that we used to think were benign, this facility spends about $6 million per year on payroll and about $90,000 per year on utilities. Pretty big utility bill for that size facility, but it also has a computer server room. With good fresh air, smart fresh air controls in this building, with the productivity gains that they should experience by having better fresh air, they would see about $750,000 drop in expenses or gain in productivity, gain in business activity. And also, as far as sick days, they would see about a $60,000 reduction in sick day costs. But sick days don't show up in the facilities budget. They're interested in utility costs. Interestingly, when we did the modeling of this building, and you can see the green line shows the average of the 6 locations that we averaged over several work days. And you see a little blip when people went out to lunch and another somewhat decrease from our model. And we could have put in a lunch break and all that, but that's noise level. That when we changed our model from that brown line to that blue line with active control, there was actually no difference in utility costs. And it actually went down a little bit because they don't start heating this building until it's in the 30s because of that big toaster oven of a computer server room. And just to give you an idea, houses of worship, yeah, generally air quality is fine because nobody's there except for maybe an hour or two. But that hour or two, that's more than enough exposure time that if someone's infected, you're going to get sick. Illinois Department of Motor Vehicles had horrendous problems, and then they put in a demand control ventilation, a smart ventilation system. And they're currently operating under today's ventilation standards. While I've suggested dropping it to 800, they just need to do what's called for, as so many other people will tell you. So when they hear me say, well, put it down to 800, they're horrified and don't do it. But they could. And you can see how this operates. They used to regularly fly into 2,000 to 3,000 parts per million as they are renting spaces that weren't made for that many people. So let's end up on COVID. And this is just to give you a little taste of what I call a COVID safe space calculator, which is meant to be a communication tool to facilitate discussions among teachers and teacher unions and administration and facilities people and PTA and students or restaurant owners and their customers, but a tool to allow more quantitative discussion. So as sick as we are of hearing about COVID, And as much as we keep hearing these contradictory and ever-changing and fuzzy guidelines from CDC and WHO and ASHRAE, the intent here is to provide you with a tool so you can do your own estimates of what's needed for your situation and have a discussion among the different stakeholders. So as I mentioned, we can predict this. This prediction that I did from the end of last July into the fall, and you can read about this if you do a search on my name in medRxiv to see several predictions and things on linking building ventilation to COVID transmission. So we understand the transmission of this and its characteristics. While there's other things we're learning about, like once we're vaccinated, as I fortunately am, that how long will that last? Or will I still be immune as variants are evolving? And will we be able to squash this thing before variants finally take a form that we again have to treat as a new disease? So this COVID Safe Space calculator that you can download, it is meant to be just a simple worksheet, so you can modify it as you would like. Over on the left are inputs, and these inputs are meant to be understandable. So standard building ventilation gives you 1,200 parts per million carbon dioxide. If you don't know what your space is, get a sensor, go in there and measure it. The exposure time, the number of people in it. And in this little drawing that's shown, you can see that this building has two ventilation systems, one that might be a main system with whatever filter bank and airflow and perhaps ultraviolet that can be selected. And then a second that might be, for example, in a classroom where you'd like to add additional filtration. So it might be one that you buy in a big box store, place in the room in 1, 2, or 3 locations, and with whatever filtration level. And then you've got immune people, you've got vaccinated people, and you've got infected people. And so as you populate this space, and then as you determine or decide how many are wearing masks or if they're even needed, and you choose an activity level, and there's explanatory notes under these, but there's also additional background material to provide you with further understanding. And then the air circulation systems, and then a couple other pieces that let you look at, for example, the impact of variants that transmit, say, twice as much as today's. And over here, the output, how much airflow this ends up resulting in, but most importantly, what's the chance that if I'm among a group of 11 people, one's infectious and 10 are susceptible, I'm in that space for 6 hours, and I have these other airflow conditions, a non-effective filter, that I've got 72% chance of becoming infected if an infectious person walks in. And then the most important parameter, the one that I need to get below 1, 7 people out of the 10 susceptibles are likely to get infected by that infectious person under these conditions. So then the multiplier, the COVID Safe Space calculator lets you mix all of these factors that interact in a complex manner, but the output, your chance of getting infected if you're susceptible, and the infection multiplier. And when that infection multiplier, what epidemiologists call the basic reproduction number, when that's less than 1, then we've defeated COVID, when we've sustained that level below 1. And we haven't been capable of doing that yet, even though it's our behavior that is largely responsible for not being able to get this below 1. We've had it in our power, our capability to do that. Vaccinations are helping to drive that, as we'll see in these results below 1. But until that gets below 1, and when that's below 1, that means one infectious person is not able to make another person infected. When that number is 7, then that person was able to replicate their disease 7 times, and that's when it's accelerating and spreading throughout the populace. And in the words of Ron Popeil, but wait, there's more. There's 2 other worksheets so that when you would come up with a solution for doubling the fresh air flow rate, adding MERV 13 filters, perhaps ultraviolet germicidal irradiation, and you're told, no, that's way too expensive. We couldn't possibly do that. Where are we going to get the money to do that? Well, go to worksheet 3 and then look at the energy impact of that. So all of that data that I just showed you on energy impact on indoor air quality, sick days, and productivity, totally separate from the COVID aspect. You can look at, oh, so sick days should go down by 40% if we go to this, and that's worth more than what facilities is going to spend on energy. And I'm in Miami, or I'm in Chicago, or I'm in Salt Lake City, or anywhere in between, that the information is in there for seeing for your weather, the impact during the summer and during the winter with various levels of energy recovery. It gives you the tools to have that beginning discussion among different stakeholders, and that you don't have to be a building science person, you don't have to be a facilities person, an engineer, or someone else in order to be part of that discussion. So it's important, though, that every space gets this infection multiplier below 1. We're all connected. And so if I'm in 3 out of 4 spaces that do that, but the 4th doesn't, we're not going to get rid of this disease. Also attached to this, and as Brett mentioned, he's posting you a link so you can get to, there's a series of YouTubes. These are under construction now, but these short YouTube provide more background on CO2 and fresh air, on filtration, on face masks, such as a wonderful study at University of Wisconsin looking at face mask efficiency in removing aerosols and droplets, on air quality distribution, and a series of examples, like we'll look at some results for is my school safe and is my restaurant safe, but many others that will get added in the upcoming weeks. So for example, with the school, let's apply this calculator, but in a manner so that different stakeholders can participate in the discussion. Teacher unions, PTAs, facilities, and administration. If we look at, say, a standard day that might be 7 hours, there's an infectious person that walks into the room, whether a teacher or a student, and no one's wearing face masks. We're using MERV 8, which are basically useless for virus filtration, and 1,200 parts per million, a nominal 20 CFM per person. And we start here as standard conditions. The calculator tells you, well, you got roughly like tossing a coin, 50% chance you're going to get sick if an infectious person walks in. And that means today, maybe you're lucky, tomorrow, maybe not, or the next day not, or maybe 4 days in a row you're lucky, and then the 5th you're not. But more importantly, yeah, this disease, it's not going to go away. Even if 50% or the so-called herd immunity, we hit this threshold of 70 to 90%, the infection multiplier is decreased, but our building ventilation is preventing us from getting this disease to finally get out. We improve fresh air. Let's drop it to 800 parts per million CO2, doubling fresh air. Hey, now it's 1 in 4 chance I'm going to get sick, 1 out of 4 days. That's still pretty high, and I'm still spreading the infection. It's still multiplying. Let's take about the same amount of air and recirculate it through a MERV 13 filter, whether it's a room filter or not. Now I cut that infection probability down again. And look, as I hit herd immunity, I could maybe even not wear a face mask and have this thing decay out. But this is still pretty high probability. So let's go to, well, it's voluntary, and there's a lot of, like a bunch of my relatives, kind of cantankerous, up around Bad Axe and Marlette, Michigan, that still don't believe in face masks or their usage, and so it's kind of lackadaisical and loosely fitting. Well, that helps a little bit, but you can get 90–95% mask efficiency. Again, read that, look at my YouTube, but find that study by University of Wisconsin. And if you get people to seriously buy in, now we're getting somewhere. The lower this infection multiplier goes, the faster this disease goes away. And then, as I mentioned, the indoor air quality, because I'm going a little slow, I'll not go over this heavily, but just to say that to back up the indoor air quality, the sick days, the cognition productivity, that at 1100 parts per million, standard ventilation is roughly a reference. As I mentioned before, that's where you'd have, say, 2.5 days sick day, 20% dissatisfaction. The brain is functioning relative to standard ventilation as well as it functions. That then as you move to say 1200, as I assume for this example, you can see air quality dissatisfaction goes up. Sick days go up by 10% relative to that standard 1100 parts per million. Cognition decreases, and there's value associated with that. And not just a little bit, a lot. And then you go to the improved COVID conditions. The conditions you set for getting COVID to have an infection multiplier below 1 also then shows you, hey, we're going to make money on just reduced sick days from flu and colds. Fewer people are going to be dissatisfied by the air quality, and that's a benefit if people aren't just sitting around thinking the air stinks in here. And a 10% cognition productivity improvement. Hey, I've essentially taken that $25 an hour that I'm maybe paying people and made them worth $27.50 an hour. That's big money spread over the number of people in that room. And over here on the energy side, it scales, as I told you, say electric or gas, about a penny per hour per person when you break it down that way. And similarly in the summer, so where this would be January results for, say, Illinois, and this would be July results. And in July for us, it's the latent as opposed to the sensible that's the more expensive, but still about 2 cents per hour per person as far as the moisture management side. And so you can get those numbers to compare with what you're doing to make this space safer for COVID. And in restaurants, same type of thing, but some different viewpoints. And I'll just mention, we ran this experiment in a local venue. We're fortunate that the University of Illinois has this extensive testing program. Students test twice a week. It's a fast test, it's a free test, and everybody buys in. So we could take a pool of 25 COVID-free students, jazz musicians, and audience, put them in a room instead of freezing outside. We did this last October. And what we found, my colleagues in environmental engineering brought their instruments, my jazz musician colleagues and friends brought their instruments, and we had a good time. And as the population grew, as we got up to about 25 people, these starred data points, and CO2 went up with the blue, as you would expect. And then this red line, 0.3 micron, but we had 0.3 up to 10 micron, but 0.3, 0.5 micron, those are the aerosols that you're releasing that are contagion laden. That built up and correlated strongly with occupancy. And when we turned on additional fresh air to dilute it, look at the particulates drop. So not all of these are contagion laden. We're shedding, like Pigpen in the cartoon, a lot of other small particulates. We have a cloud around us. And some of those are the respiratory ones, a small fraction. But overall, we're inhaling about 64 million of these small particulates at this level of concentration. And while that might be horrifying, that many particulates are going in you, it's actually a real tiny amount. And the cilia in your epithelial cells are bringing that out, and you're either swallowing it or getting rid of them in other ways. It's a magical system to manage those. And then when we turned on a filter, you can see a further drop. So we turned on the filter, turned off the fresh air, and then with both, we could keep it down. So this is real, that this manages those particulates that are laden with contagion. And so in this restaurant, looking at, say, a customer viewpoint, 111 customers, which this thing would regularly have when it's filled. Say a 1 to 2 hour exposure, I've assumed 2 hours, one infectious person. The interesting thing over here, unlike the smaller classroom, is that an infectious person here may not have as high of an infection probability for the susceptibles, but they are typically able to infect that many more people. And in this case, for somebody who's in there just say 2 hours, that the multiplier is still unacceptable. But look, as we improve fresh air, as we add MERV 13 filtration for customers coming in without masks or eating and masking and non-masking, that we get the infection multiplier below 1. The disease among the customers is not going to transmit. We have some level of masking, we have better level of masking, it drops down. Now, the staff viewpoint, the frontline workers, as they are in so many, they're the ones spending a longer time exposed, and that's really where we have to concentrate. That one infectious person, whether a worker or one customer after another of this continuing 100 and so occupants, this is where the disease is going to propagate. This is who is most likely to get sick. And this is who we need to have the building conditions as well as the masking protect to finally get down to where, with enough vaccination, enough immunity, and effective mask wearing, we can decay and kill this disease out. So I'm just going to go on to the last slide. I'll say, here's the perfect office. We built this in this mechanical engineering building I showed you that's under renovation and construction. But we just wanted to demonstrate that there's all the fresh air in the world on the other side of that wall. It didn't need to go through a lot of duct work. There are CO2 stats and VOC stats that you can put in place, as well as, wouldn't it be nice to have your own comfort, personalized comfort, plus personalized air quality in your own office? And this is an undergraduate advising office, a heavily trafficked office. And it was the best office on campus. Others in these poorly conditioned offices, over windowed, you see we cut the window area in half and made this an insulated panel, and this was double glazed. This office was comfortable. And this excellent study by the Center for Built Environment at Berkeley found that with over 30,000 people spread among over 200 buildings, 80% of buildings don't even meet the 20% dissatisfaction level, that more than 20% are dissatisfied with air quality and comfort. What a horrible product we're turning out in buildings. Would 20% car defects be acceptable, or any other product? I don't know any other industry that can turn out such a flawed product and still exist. So I'll leave it here. Our buildings are making us stupid, sick, and tired. And controlling fresh air, getting it to 800 parts per million, this is equivalent to doubling it. Filtering it properly, this is going to reduce indoor air quality dissatisfaction for those commercial and institutional. That means more people willing to come in to your business. For sick days, it's going to drop it collectively among all of us if we can get our ventilation rates by 40%. And then productivity is going to gain. And maybe that's a child that we don't consider being productive, but an expense, but they're going to turn into a productive person, and making them have a better classroom and better home environment for improving their learning and education is critical to sustaining the future. So I'll end on that, and then I hope that you'll contact me or Brett with your interest in learning more, because we would like to have more targeted meetings with folks in your schools, in your businesses, with whatever groups you're associated with, to discuss how to create a safer, a COVID-safe environment, as well as improving the air quality and productivity in the space around you. Thank you very much. Be glad to answer any questions that you have.
All right, thanks, Ty. Can you hear me all right?
Yes, I can hear you fine.
All right, great. Yeah, let's get into those questions. We can stick around and have a good conversation here. We got a lot of questions coming in. Before they come, for those of you who got to get going, I understand. You're going to get your
Sorry
certificate.
about that.
No, that's fine. Check your spam, and if you need it, check it from customer care at gotowebinar.com. That's where your certificate will be. And if you're looking at this in the future on demand, not right now, take that quiz, 80% passing rate. You can check it out on our Thinkific channel or on the GBCI channel or wherever else you might be watching this session. And as always, a huge thanks to our board of directors, our volunteers, our new executive director, Jose. A huge thanks to our top tier sponsors, Mitsubishi, Ream, and Build Equinox Serve, all helping us spread this message and helping you build better. So somebody brought up something I didn't know about, and that was a calculator done by MIT. And we posted in the chat for all of you. It's in there, a link by Martin, and it's Bazant, B-A-Z-A-N-T. So their question to you was, how does yours compare to that one? Have you looked at it enough to be able to make an informed decision? Is there something missing from theirs? But yeah, I never heard of it before, so I didn't know if you had any.
No, I'll mention that you'll find a number of calculators out there. The MIT, the University of Colorado has a calculator, and all of us share a similar basis. This airborne transmission uses what's called a Wells-Riley equation, but it's basically that you assume an amount of contagion is being released by an infectious person. And when you inhale an infectious dose, and an infectious dose is called a quanta, but you have, say, a 63% chance of coming down with that. You inhale 2 infectious doses, now 90% chance. And so we're all kind of calculating for the amount of contagion coming out of someone's lungs. And if a certain fraction of that's caught by a mask and another fraction that's then released into that air gets diluted by fresh air or filtration or that. And then if you wear a mask, and one of the important things for schools is that the difficulty you may have in keeping, say, young children or others wearing face masks effectively. If you effectively wear your face mask, just like a medical worker, your chances of getting sick are drastically reduced. So getting a good N95, KN95, 95% efficient mask, wearing that religiously in the building, because it's not just that person 3 feet or 6 feet away, it's in the air, that will protect you. So the University of Colorado, the MIT, all good models and using similar modeling basis. The distinction I would make is that I come from a boots on the ground. I'm somebody who's climbed through equipment in buildings for 50 years, from when I worked in buildings and ventilation and heating and cooling as a young engineer, to then when I turned to, I was going to say the dark side, but the academic side of the ivory tower and studying these my whole life. But, building this 0+ energy house that I'm coming to you from, that is smart ventilated, has enough energy for 2 electric cars driving 8,000 miles a year, and rainwater harvesting. So, I mean, I live and breathe this stuff, but this COVID Safe Space calculator is a boots on the ground calculation. And it's not just COVID, it's indoor air quality, it's productivity, it's sick days. And then on top of it, what I don't think is in MIT or Colorado or some of the other models I've seen is then the facilities costs. So in this model, you can get your own weather data, or in another part of the worksheet where you can grab Miami or Chicago or 250 locations, get the monthly extreme for winter and summer for that location, and get the latent sensible cooling, as well as the, if you do put in energy recovery, like a number of businesses that we're working with are doing, that you can then see the cost impact and the payback. But on the energy recovery basis, that don't sacrifice human health, and then when you see what ventilation you need to keep people healthy, then look at, does energy recovery make sense? And I'll guarantee throughout the country, it does make sense to recover energy. The cost, about $10 to $20 per cubic foot per minute installed costs, just like Campus Church on campus, as they're putting in about a few thousand CFM energy recovery unit. And so it gives you that cost basis. So when you're all sitting at the table, facilities people, administration, parents, teachers, you can look at the dollar side, but then look at the impact on your health and productivity.
I'm glad you brought up there's a cost, right, to the energy for ventilation, but someone else, one of our other guests, and I hear this before, there's of course that cost behind it is of course emissions, right, CO2 emissions, and so of course their concern was that, and I don't know if you've seen that picture kind of going around early last year where there's like a shark, right, and there's like 3 sharks, right, and the top shark says the economy, the middle one says or the top one says COVID-19, the middle one says the economy, and the big shark eating them all is climate change, right? So they're like, hey, the trade-off to make us temporarily healthier in our space is going to add more emissions to, inevitably, kill us worse from climate change.
I couldn't agree more with that statement. Right. That, I'm not someone that's online very often or that, and so, you're not going to see me. But let me tell you the truth, and you can see this in a number of my other writings, so that's a totally different topic, but every dollar that's shifted out of fossil fuels over to renewable energy and energy efficient devices like heat pump water heaters, heat pump conditioners for comfort conditioning, heat pump energy recovery units, every dollar shifted out of fossil fuels over to better products is a 10 to 1 increase in jobs. And finally, people are seeing that, as you hear former Secretary of State John Kerry say, that this path to defeat climate change, to create a sustainable world, is the economic path. And so that is absolutely a false premise that improving our indoor environment is going to waste resources and pollute us more. It's absolutely untrue.
Yeah, and just to address it, and I agree with you. I mean, I think that's a false choice that we have to make. We can do both. You showed it. I recently, and I'm going to put more information out, but I recently added an energy recovery ventilator, a MERV 13 that I filter all the time, and a radon system, right? Yeah. And those alone are maybe pulling 500 watts, right? Like it's such a small portion of the pie compared to anything else I use in my house that it's there's barely any trade-offs there to live healthier and be able to like as you said, be able to even think about what I'm doing right now because I've got proper CO2 control in my house. So
yeah. And so let me mention along those lines as well, and I'm glad to send a paper that I've written on this topic, but using Fortune 500 data from large corporations and their employment relative to their revenue. When you look at fossil fuel companies, they make about a couple $1 million per employee of revenue. And who else makes that type of money per employee? Well, investment banks and healthcare industry. And so you got fossil fuels and investment banks and healthcare. And then you look at companies that make things like a Whirlpool, a Ford, a solar panel manufacturer, a wind turbine manufacturer, and you find that an employee in those companies generates about $200,000 to $300,000 in revenue rather than $2 million. And that's why when you shift to a heat pump water heater that's now going to employ somebody to make that essentially window air conditioner that goes on top of your water heater tank, and now you don't have to use now you don't have to use as much gas to heat your water, whether at a plant for electricity or in your water heater. You've taken $1 out of that had a tenth of the number of jobs, put that into an industry that has a lot more employment, even in today's automated manufacturing. In addition, these two unrecognized water heating heat pump clothes dryers, same thing. A heat pump clothes dryer, put a basement dehumidifier inside of a clothes dryer. You can dry clothes 2 to 3 times more efficiently than you can with a standard dryer. And of course, a clothesline's even better. But in a family of 3 to 4, a household of 3 to 4 people with a heat pump water heater and a heat pump clothes dryer, that you're going to save enough, you're going to reduce the energy, improve the energy efficiency to save about 3,000 kilowatt hours a year. And that's enough for about 10,000 miles of electric vehicle driving per year. And that means that those two taken for granted uses in our house can supply a household with most of their driving. And then with all the other great things that your other speakers have talked about with net zero homes, other ways to save energy, we're going to use much less energy to stay as comfortable and to get healthier and to have more resources to spread around and more jobs. So I'm just pinching myself that the future is very bright. But of course, there's the naysayers, and just like the tobacco and sugar industry, they're going to fight like hell to try to stop and delay it as much as they can.
Right. Yeah.
So that's enough of that right now.
You know, you make a good point, and yeah, I mean, there's so many simple things that we can do to save significant amount of energy, so that the trade-off, there really isn't, you know, an issue between proper health indoor and energy conservation. They go hand in hand. We know that. We've been saying that. You talk a lot about worker productivity, and I really appreciate some of the folks here in the chat here just really bringing up the schools part about how, you know, these kids aren't necessarily making anyone any money, right? But they are in urban settings, especially. A lot of these schools are in terrible disrepair. There's asthma running rampant, all sorts of other problems. And so now we have these funds that are all of a sudden like magic have appeared, right? Whether some people agree with that or not, they're there, and they're there to fix these issues because of COVID. But take advantage of them. Take advantage of the one I posted from Eagle to get it into your school system in whatever state you're in. Every state's probably got distributed funds from the relief bill, and more coming their way to improve infrastructure. And so, you know, this is going to help, you know, I assume resolve those issues, right? Like indoor air quality with asthma with kids, right?
Well, it might if building standards improve, but right now there's a lot of battles going on. So I'm regularly speaking to local ASHRAE groups, and in May I'm giving a talk in Nessie on the basically acceptable building ventilation standards. Because as much as I respect ASHRAE and have been a member for decades, and it's been important to my career in many ways, helping to educate me as well as connect me with others, its committees are basically playing offense and defense among the industries that are members. And for example, when the gas industry is able to keep the ventilation standards so that indoor cooking with combustion is not treated differently than electric cooking, there's a big problem. It's not going to be innovative. It's not going to move. And so to me, I think the way that happens is us outside of that have to create this new standard and get things to move so that then an organization like ASHRAE can see that they're being left behind, as everyone else says, look, I can do just like my house. You know, we got down below zero this winter. I'm not going to sacrifice and go less than 40 CFM per person in this house when this house is occupied. And that's the other thing about smart ventilation. This house doesn't need any ventilation when we're not here. And so that's how you get energy savings plus a healthier building environment simultaneously.
Yeah, Yeah, I've got to go down into the dark depths and turn off my ERV when I leave, if I remember to do so. Otherwise, it's like, what's it doing, right? What good is it? You
Well,
know?
soon you can just say, hey, Google, or ask Alexa to do that,
Yeah, that's
wherever
coming.
you are.
So on your calculator, which was the session topic here, is positivity rate a formula that someone needs to know to put in to help make them make them? Is there a
But
reason it's not in there? It seems like it should
yeah,
impact.
it's not, but here's how you account for that. Positivity is kind of a screwy number, right? Because right now, except for where I'm sitting in Champaign County, Illinois, with what is probably the most extensive testing program anywhere in the world. So when they say positivity and it's like 0.2% of the populace, I mean, we really do know within this campus environment that 0.2% of the people do have COVID and are infectious and possibly spreading it. But when you see 5% or 10%, and it's just of that small fraction of the populace that may be getting tested because they think they might have COVID, that's where it's kind of a difficult number then to understand what that means. So let's say that if we truly know the positivity number, and let's say it's 0.1%, it's gone up recently, but if it's 0.1%, then one person out of every 1,000 people is infectious, and they're infectious for about a 14-day period. So when we say, okay, this restaurant will have, say, 100 people in it each night, and if one person out of 1,000 in that community is infected, that means 1 out of 10 days, there's probably going to be an infectious person. Okay, so 9 times out of 10, there's probably not an infectious person. And then the 10th time, there may be an infectious person. But of course, it could be, out of 90 times, and then 10 days in a row, there's an infectious person going in. So you've got to watch the statistics on these things. But so when you make a COVID safe space, then you can use that positivity to kind of know how many days, there might be an infectious person coming in. So that's kind of a moving target. But most communities, with the exception of Champaign County, don't really know what their real positivity rate is.
Right. Is it probably then better to say, well, it's not in there because you should just assume the worst, right? I mean, you should assume someone's infected all the time, right? I mean, is that, yeah.
I think until your community can report that COVID is no longer reported in this community, you need to just assume there's somebody infectious that may be around.
Right.
And for those folks who are unfortunately unable to, for valid reasons, to get vaccinated, we need to be protecting them.
I guess I also wondered,
wearing a face mask. Everyone needs to be wearing a face mask if you feel it's important to protect those who really can't protect themselves.
I guess I also wonder if this is the time now to keep the things we do in place, assuming that there will be more infectious airborne diseases that will just spring up. We could probably halt them faster if we keep these mechanisms in place. I mean, is that a good argument, or?
Oh yeah, keep a face mask handy. I hate wearing face masks just like everyone else does, but I'm going to wear it on the aircraft anytime I'm flying now. And perhaps if we, with seasonal viruses like the flu, perhaps with this improved ventilation, because we have absolutely seen the flu drop down between flu vaccination, people largely trying to improve ventilation or filtration as much as they can within their current means, and wearing face masks. Perhaps we can get rid of the flu too and knock it out of existence, as well as finally getting COVID out of our communities.
Yeah, that would be great to be able to do that, or at least significantly reduce it. So, I mean, there's some really good conversation really good questions here. And I think what we'll do is probably just plan on trying to figure out a way that we're going to launch something a little bit more, or you will, with Build Equinox, and we can direct people that way to start diving into some of these conversations. I did post a link there, the one you had sent me earlier, that kind of brings folks over to both the videos you've already created and then the ones you plan to create. And so I assume they can bookmark that and keep checking back maybe, or we can send out some announcements as you add more.
Yeah, and for those unaddressed questions, maybe you and I can do a separate recorded piece covering them, assuming I don't rant too much about them, or I can write up a written response that we can post. But let's take a look at that and make sure we address those questions.
Yeah, no, I have them saved, and I'll get them over to you. So maybe when you respond back, you can send them out. But I think overall, this has been a really good conversation. Appreciate having you back here. I'm soon we'll catch up with you in a little bit about some other items.
Thank you for participating, everybody who's hung in there and stayed with us. But thank you very much for the opportunity.
Yeah. All right, everyone. Well, we're going to head out. Stay safe out there. Get vaccinated. And we'll hopefully catch you all at the next one, and then for some session in person over a beer someday soon. So I'm looking forward to that.
I'd love to get back to Founders. Thank you.
Yeah. All right. Take care, Ty.
Be sure to check out all of our courses available online that you can watch anytime and anywhere to pick up your CEUs. Before you go, make sure to subscribe to us on YouTube to get weekly updates and stay up to date on green building science courses, webinars, and home tours. Thanks again.